So this section of the tutorial is going to go over data types. So the different kinds of data that you can store in variables. So when we defined the variables before, like when we were using integers, so we typed int in the name of the variable. Well, instead of
familiar,
right. So instead of int, there's a bunch of different types of data types that we can use.
So let's go ahead and start with the very first one that we have listed here, and that is a char. That is short for the word character. A character is going to hold a single character. I believe it holds 1 byte of data. A single character will be like a single A, B, C, anything on the ASCII chart that is a single 1 byte character, it will hold that.
It could even be a blank space, or it could be a null, or it could be an asterisk, or an exclamation point, or a number. But the program won't interpret it as a number, it'll just interpret it as just a single character.
Right, it will come in handy perhaps if you write a program and you give your user an option, press, or would you like to continue, Y for yes, and for no. They can just put in that single character, and that in turn will save space later on, as opposed to using it, setting aside a giant piece of data like a string, which we'll get to in a minute.
Right, or if you're converting from hex, and so you had somebody typing in, a hex value with characters as well as numbers, and you wanted to kind of take those and, do a conversion on them. Characters are very useful.
The next one that we're going to talk about, which we touched on already, is the integer.
Yay!
Yay! An integer is any positive or negative whole number. That could be 1, 2, 3. It could be a bajillion. It could also be negative bajillion.
Right.
It doesn't really matter. As long as there are no decimal places, it is an integer data type.
Right. The integer you'll probably use the most.
Yes, when you do counting loops, things like that. It's not necessarily good for division unless you want to get the whole number equivalent, or if you are 100% certain that you will return a whole number.
Right.
If you were to divide, 10 divided by 5, you're going to get a whole number.
Right.
If
10
you were
divided by 3,
you won't get a whole number.
Right. It'll just kind of round it up.
If you do 10 divided by 3 and they're both integer data types, it will take the number before the decimal point, because it does not set aside memory for decimal places. The next one we're going to talk about is the short integer.
So this is pretty much if you just want to save on memory, if you're using a whole lot of integer variables. The largest number that you can use is shorter, just so that your program's more efficient memory-wise.
Right, I think you hit it right on the nail. It's about efficiency. If you are doing, let's say, a loop, and you're 100% certain that this loop will never exceed 10, or a small integer size, you don't have to use integer and use all that wasted memory space. You can do a short int. It makes your program a lot more conservative. It'll actually make it more efficient, and if it's a humongous program, it's going to actually make it run a lot faster. Alright, so we'll continue next to the long integer, which is the complete opposite.
Right, so if you have some integers where you really need, you're handling a bajillion, for example,
perhaps.
so and you need that memory space, this is where you want to specifically define it, since you're gonna it's gonna be a longer number than just saying int.
Yes, you can kind of look at this basically. If you're sure that you're going to be using astronomical numbers or very large numbers, it's good to set aside enough space for them. So if you know that you're going to be using a big number, use a long. However, if you don't plan on using long numbers, don't use it, because it does use a lot more memory space. The next one we're going to talk about is the fun data type to use, the good old bool.
Yeah.
Talk to me, Brian.
That's short for Boolean.
Yes.
So a Boolean value can only be true or false. There's no other value that a Boolean can be.
That's correct. That comes in handy when we talk about functions. When we send data out to a function, the function can either tell us whether to continue or not. Like if we said that, if after you do this calculation it equals 1, give us true. And then based on that value, we can execute the rest of the program.
Right, so maybe if it doesn't run correctly, it'll return false, and we'll say, oh, well, that's false, this isn't correct, this isn't lining up, we have to do something else.
I think it's easier to see the bool in action, so when you see it in action, you'll definitely get a good grip on how it works. Now let's talk about the float.
So the float is a little different from the int. Ints are whole numbers, whereas a float is a real number. So with a real number, you can have a decimal whatever you want. So
in this, the float sets aside a certain amount of decimal places. Off the top of my head, I'm not exactly sure, but it will set aside a certain amount of decimal places for a number, and this also will bring us into the very next one and why we need to use the double data type.
Right. Now also with float, you can define how many, what that precision is. So if you want, if you want to store a float up to 4 decimal places, you can define that, or however many that you need. So a double is very similar to float. It just gives you, it's kind of like long int is for float. So a double is just, it allocates more memory for a float, and you can use, you can store longer numbers. In addition to that, you can also define your floats in scientific notation.
Mm-hmm.
So you could say 1e to the 9th, and that'll be 1e9 is equal to 1 times 10 to the power of 9th.
Right.
Fun stuff.
Long double, very similar to the double. So we won't even go into in depth about it. Just know that it does exist. The very last one is also a very fun data type to work with. A very frequently used data type, and this is called the string. Brian, tell us about the string.
So the string is just a list of characters stored in one variable. So like before when we did that cout function, and inside the quotes we had "Welcome to C++." Well, inside that quote is a string of characters. You can almost see the characters, like threaded together with little strings and so on. Or not.
So it can hold a sentence, it can hold a word, a small paragraph, pretty much anything.
Or a single character if you want to.
Yeah, or it can hold a single character.
Or nothing.
Or it could hold nothing at all.
Right.
That is correct. All right, so why don't we see what they look like in action.
All right.
Back in Dev C++ here, let's start a new source file. So we'll select our source file. And while I type out the basic layout of the program, Brian's going to tell you about what we're going to do next.
Okay, so basically what we're going to do is we're going to use variables to just make a simple arithmetic table. So what this is going to do is we'll have maybe 2 variables, and if you multiply them you get this value, if you divide them you get this value, and so on. And so this will, in this example we'll use a float, an int, and maybe we'll output something to the screen with a string value.
I'm going to call it variables 2. All right.
It runs.
We are good to go. So are we going to try every single data type here? How exactly are we going to go about this?
So we're basically just going to cover int, float, and string.
So let's talk about the integer real quick. We mentioned before that an int is a whole number, and we kind of played with them in the previous example. But let's look at the limitations of the integer. Like if I did int x equals 1, and then I did int y equals 2. What would happen if I did int z equals x divided by y? So 1 divided by 2 is going to be 0.5, right? Let's run this program. Let's see what it tells us. 0.
Because it rounds it down.
Right, like we talked about before, it takes the integer value. If there's anything after that, it won't do anything with it. So we can declare these as as floats, and we will get that 0.5. We can run this.
So now this is going to allow for decimal places, and there's the 0.5.
Yeah, excellent stuff right there.
So now let's use these 2 variables to make a quick table. So let's say we have float x and y, and let's also define a string value of, we'll call it the message, and the message is data type table. So there's our little message. So the first thing that we want to do is we want to output the values that we're using and the message. So cout and the name of the string, and it'll write that to the screen. Do an end line, and we'll say x is equal to x, and add some space in here. Y is equal to y. So if we want to add these together, let's say, let me add an end line in here to keep it pretty. So on the next line we'll say x plus y is equal to x plus y.
You sure that's going to look right? Sorry.
Bless you. And
Alright.
we'll start a new line. And cout x minus y. Actually, I'll just copy this line and we'll just do this a little faster.
One thing that you also might want to do is erase the cout z end line at the end there that I put in. Way right above system pause.
Thank you.
Hey, you're welcome, buddy.
Alright, so we'll add 2 more couts. So what we'll do here is we'll do subtraction, multiplication,
Or addition.
and division.
You gotta do the multiplication sign is not a plus sign.
Oh, I'm sorry. Thank you very much.
Hey, I'm on top of you, my friend. I'll give you the driver's seat. I expect you to be good.
This is why it's wise to never program alone. And I did it again.
You made the same mistake again.
Yeah, really. What's up with this keyboard?
See, this is why I'm the programmer and you're the concept guy.
Right. Alright. Okay. So when we run this program, we'll see that we'll run into the same problem we had before with the division. So let's do the number 1 as 10 and the number 2 as 3, so it's not quite so clean. And I'll hit F9. Alright, so x plus y equals 13, so it works fine for addition, subtraction, multiplication, and division. Because they're just, they're stored as floats. So let's say if we want to store this as an int, compile it again. It also works. So long as you have one float value, it will assume, it'll take that integer value and just kind of append decimal 0 at the end of it.
Okay.
And it'll, so you have to have at least one float in your algorithm to kind of allow for that.
Now this kind of brings up another thing, and it's kind of off topic, but I think it's important to talk about. Let's do a quick conversion.
Okay.
Let's define both of them as integers at the top.
Okay.
And see, since this is going to work just fine for everything except for division, we can typecast. We can actually convert an integer to a float at compile time.
Right. So as you see here, x divided by 9 is equal to 3, opposed to 3.33 bar.
Let's just suppose that you want to use something as an integer, but there's one circumstance where it would help to have it a float.
Right, like this last line.
Right. Let's do that. So
okay.
what we're going to do is we're going to right before the x.
Oops, I'm sorry.
Actually, I think we're going to have to do that to the individual x, because if you do that, you're going to make the whole number a float. You know what I'm saying?
Yes, I do.
So you're going to just encase the x, and then do it to the y as well. Alright, well, Brian added some parentheses to the outside, which aren't 100% necessary.
No.
But basically what we're doing is we're saying we do float, and then encased inside of the parentheses after it, we're sending it to a function that will convert the value of x into a float.
Mm-hmm.
And it's a very simple way of doing it. It's built into C++, so push F9 right now. So now we've converted them at compile time to, at this point of the program, we're not changing x. That's the important thing to note. We're just saying at this particular part, think of x as a float, so
right.
when we get this output, we can make it a float. But it has nothing to do with changing the value of x.
Mm-hmm.
Okay, so that's very simple integer float relations right there. So, next.
So also, as we noticed here, we had defined a string called message, and this is the message at the top of the program that kind of says, this is the data type table. So if we want, we can also define another string, and we'll call it append message. And we'll say, in quotes, welcome to the, and sort of similar to like adding integer values, you can kind of use the plus symbol to concatenate strings and put them together. So what we can do here is we can say append message plus message.
Mm-hmm.
And so that's going to first display welcome to the, and then add to it data type table across the top. That's the first thing that's going to output. So when we compile that, welcome to the data type table.
You are the master programmer. Dude, erase everything real quick except for the strings. Alright, so make another string.
Okay.
Just call it string total message. Alright, so, and then make total message equal.
And we'll just store it as something blank so we don't get that whole, garbage from memory.
Okay, and just right underneath it, you can do total message.
Oops.
Must
total? Yeah, variable names must be one word with no spaces. So the string total message, we're going to store a value.
Yeah, we can make total message equal append message plus message. That value down there.
Right. So I'll just cut and paste it here. Semicolon and the command.
So now we could just simply see out total message.
So now we're storing this concatenated with this as this variable name. And we'll display it here. And there's our total message.
Okay. So that pretty much concludes the basic data types.
Mm-hmm.
Good way to end it right there.